rate law or rate equation or rate law expression. What is the rate law? Rate law is the expression in which reaction rate is given in terms of molar concentration of reactant, with each term raised to some power which may not be same as stoichiometric coefficient of the reacting species in a balanced chemical equation. For example, here I am taking A moles of A plus B moles of B gives rise to product. This can be given according to this definition. Rate is given in terms that is directly proportional to the concentration of A power X, concentration of B power Y, then R is equal to K A power X B power Y. So now according to this is called rate law. In this rate law, the powers, these are the powers. These powers may not be same as, now x equal to maybe A or x not equal to A, y equal to B or y not equal to B, may not be equal to stoichiometric coefficients. So if they are not equal, meaning therefore this rate law is experimentally determined. So this rate law already I discussed in the previous video, definition and this equation. Example here, one more I am giving general, that is called 2NO plus O2 gives rise to NO2, 2NO2, 2 nitrogen, 2 oxygen, 2 oxygen, 4, this balance. Now, with respect to this equation, I will write the rate law. Rate law is equal to K NO concentration power 2, O2 concentration power 1. So here stoichiometric coefficients are equal to that powers. So x equal to 2, y equal to 1. Stoichiometric coefficients are, here 2 is there, here 1 is there. Therefore, these 2 and 1 are equal, but sometimes may not be equal. Order of reaction, that is denoted with the small letter n. Definition of order of reaction is the sum of powers of the concentration of the reactants in the rate law expression is called the order of the chemical reaction. Now this can be explained same, A moles of A plus B moles of B gives rise to product. Its rate law expression is R equal to K A power X B power Y. Now these powers X and Y, these powers is a sum, N is equal to X plus Y. This is called order of the chemical reaction. So already we studied in the rate law, these x is equal to A or x not equal to A, stoichiometric coefficient, y equal to B or y not equal to B. Therefore, order rate law is experimentally determined. When rate law is experimentally determined, automatically order of reaction also experimentally determined. So what you call this is order of reaction is experimentally determined. Why this experimentally determined? Because of this reason. Some example related to this. Example 2NO plus O2 gives rise to 2NO2. Rate law is equal to KNO concentration power 2 O2 concentration power 1. Therefore, here N is equal to X plus Y, that equal to 2 plus 1 equal to 3. So this can be explained as order in A, otherwise, sorry, not A, NO. Order in NO is equal to 2. Otherwise, this is called order with respect to NO, that equal to 2. So here in word may be used with respect to 2, or like this used that equal to 2. Another one, order in oxygen is equal to 1, or order with respect to O2 is equal to 1. Now N is equal to, that is called X plus Y, that equal to 2 plus 1, that equal to 3. This is called overall order of reaction. Now this can be explained with another example. Example number 2. This is example 1. Now already we know that chloroform CHCl3 react with the Cl2. This gives rise to CCl4 plus HCl. Its rate law given in terms, that is rate is equal to K CHCl3 concentration and what do you call Cl2 concentration power 1 by 2. So this can be explained as order in chloroform is 1 and order in chlorine is equal to half order. Now overall order of reaction, that is N equal to X plus Y, that equal to 1 plus 1 by 2, that is called 1 and half, that is called 1.5. Otherwise this can be represented 3 by 2 order. Next one. Next example is CH3 COOC2H5. This is one ester functional group, is known as a ethyl acetate. This ethyl acetate on hydrolysis, this will be converted into acetic acid plus C2H5OH. Its rate law given in terms of rate is equal to K CH3COO C2H5 concentration and H2O concentration. This is power 0, here power 1. So now order in CH3 COO C2H5 is equal to 1. Order in water, that is equal to 0. Overall order, that is n, is equal to x plus y, that equal to what do you call 1 plus 0, that equal to first order reaction. Therefore, order of reaction is experimentally determined, but it cannot be deduced from a balanced chemical equation. So, based on this reaction, we can conclude that order of reaction n is maybe negative order or zero order or 1, 2, 3 order, but order greater than 3 are rare. That is called order n equal to 4 are rare. Possible, but it is rare. Next, n is maybe fractional, like 1 by 2, 3 by 2, any number, dash dash, etc. So order of reaction may be negative or 0 or 1 to 3, but greater than 3 are very rare. Possible but rare. N is fractional, also possible, half order or 3 by 2 order. So these all are experimentally determined from balanced chemical equation we cannot determine. Rate constant or a specific reaction rate constant. This can be, we know that according to rate law. So according to rate law, rate is equal to K reactant concentration power N. Now K is equal to rate divided by reactant concentration power N. N is what is that? Order of reaction. So this we can calculate when rate is known and reactant concentration and order is known. For example, units of the rate constant. What is the unit for this? Rate unit, already we know that mole per liter, and concentration unit we know that mole per liter whole power n is there. This can be written as mole and liter, and this liter per n can be written numerator liter power n, and this mole can be written as numerator mole 1 minus n, and here rate unit is a mole per liter per second. So here per second. So here when it goes numerator, second inverse. All these together can be represented as mole. Now I am taking this mole and mole. Base is same, power will be added. Therefore 1 minus n. Next one, liter. Liter same, therefore power will be added. Then this is called, so this can be represent, one mistake I did, that is this one is represented as a liter inverse. So here power will be added, meaning n minus 1. And next mole complete, liter convert, then next one is a second inverse. So this is a k units for k. In general, mole 1 minus n, liter n minus 1, second inverse. Very important, this is for rate constant unit. Now we can write the units for the each order reaction. For example, n equal to 0, zero order reaction. For this, I can write K is equal to mole 1 minus 0 and liter 0 minus 1 second inverse. This can be written as mole liter inverse second inverse. This is the unit for rate also. So they may ask the question, which order reaction units are equal to rate units? So this is zero order also and also rate units also. Rate unit is equal to zero order rate constant unit. Next, n equal to 1, that is called first order reaction. K is equal to mole and that is 1 minus 1 liter 1 minus 1 second inverse. So 1 minus 1 is 0, any power 0 is 1. 1 liter 1 minus 1, that is 0, any power 0 is 1. Therefore 1 into second inverse, that is second inverse. Next one, n equal to 2, second order reaction. In this second order reaction, K is equal to mole 1 minus 2 liter 2 minus 1 second inverse. This can be written as mole inverse 1 liter 1 second inverse. This is for second order reaction. Next, n equal to 3, that is called third order reaction. Then K is equal to mole 1 minus 3 and liter 3 minus 1 second inverse, that equal to mole inverse to liter square second inverse. So these are the orders and their units. Now one more example, that is taken as a n is equal to fractional order, then K unit is equal to mole, then this can be written as a 1 minus half liter, that is half minus 1 second inverse, that equal to mole minus 1 by 2 liter, for this plus 1 by 2 liter minus 1 by 2 and second inverse. This is for fractional order reaction. So you can take any number and put here n equal to that value and get the units. Next, determination of order of reaction. So how to determine this order of reaction? 1. From rate law. What is the rate law? R is equal to K reactant concentration power N. So this N is the order of reaction. This N is equal to order of reaction. Second one, how to determine the order of reaction? From rate constant units. For example, K unit is the second inverse. Then which order reaction this is? The first order. Next, mole inverse 1, liter 1, second inverse 1. This is which order reaction? N equal to 2. Like this we can determine the order of reaction. Then third one, from elementary reaction rate law. What is elementary reaction? The reaction which carried out in the single step, which is carried out in single step. Example, SN2 reaction. SN2 reaction is bimolecular but order is equal to 1. Sorry, order is equal to 2. There, how many molecules are participated in the reaction? 2. Therefore, molecularity is equal to 2, order also 2. Next, how to determine the order of reaction? Then fourth one, that is reaction condition. Because reaction condition change mean that mechanism also change. When mechanism change, so elementary reactions also change. So in that any one of the step is a slow step. In slow step respect to only rate law determined. Therefore, reaction condition respect to also this order will be changed. Example, we know that this is CH3. 1 minute. R is equal to K ester hydrolysis already I explained, and here this is a H2O. Look like this is the second order, but with respect ester is first order, with respect to water is a zero order reaction. So with respect to reaction condition also it will be changed. Next, fifth. In this fifth, how to determine the order of reaction for complex reaction. For complex reaction mean what is that? The reaction which carried out in more than one step. Carried out in more than one step. That is called order of reaction. So for complex reaction, order is the slow step. The slow step, it means that is called rate determining step. Molecularity is equal to order of reaction. Previous 5. Now, next, what is the number? 6. Then, sixth one is order of reaction can be determined from the graph. So, this is called from graphs. One example I will give here. Rate is equal to Ka or reactant concentration power 0. Nothing but rate is equal to K. First order, rate is equal to K, reactant power 1. Rate is equal to K, reactant power 2. For this each one, graph can be drawn like this. This is called rate and this is called concentration of reactant. Now first one is rate is do not depend on the concentration of reactant, therefore this is a constant straight line. And next one, first order reaction is rate and this reactant are directly proportional. Therefore, for example, I can draw like this. This is a first order reaction. Next, rate and reactants are directly proportional. Now, second order is rate and reactant concentration is square is there. So, this is a parabola equation type equation. Now, this can be given as like this. Rate is directly proportional to the square of reactant concentration is like this. So, this is from the graph also we can determine the order. Next, seventh one is T-half method. It means half-life method. This is half-life method. So this half-life method for each order is different. So based on that also we can determine. So I will give one example for zero order reaction. Half-life formula is that is R naught concentration by 2 into K. 2 and K are constant, therefore T half is directly proportional to R naught concentration. Next, first order reaction. First order reaction formula T half is equal to 0.693 divided by K. Taking graph for these, I can draw this is a R reactant concentration and T half. The first one taken that is directly proportional, therefore straight line. Because we have T half directly proportional to reactant concentration, initial reactant concentration. Now, if we take for the first order reaction, this 0.693 constant, K also constant. Therefore, we can draw with respect to first order, this is horizontal straight line. By using graphical methods and half-life method also, we can determine the order of reaction.